Okay, this will be the first video for alkanes and cycloalkanes. And in this video, we're going to start talking about nomenclature. So briefly, let's talk about what an alkane is. An alkane is what we call a saturated hydrocarbon, which means that the carbons have the maximum number of hydrogens that they could possibly have on them. Another way to look at that is that there's only single bonds between carbons. Alkanes, their names end with ane, A-N-E. So you can see some examples here. We have propane, butane, pentane. These are all examples of alkanes. Many compounds have what we call common names. So for example, here, this is formic acid. That's the common name. This is urea. We have morphine, so on and so forth. So you'll see that a lot of compounds, again, have these common names, but there's just so many molecules that we can't give common names to every single molecule out there. We would never be able to remember all of them. So that's where these rules that we're about to learn come from. So we're going to learn what we call IUPAC nomenclature. IUPAC stands for the International Union of Pure and Applied Chemistry. And these rules give you a systematic way to name molecules. So that way you don't have to remember common names of molecules, though there are many molecules where we just use the common name, and the IUPAC has adopted the common name. But for the most part, in these rules, there's systematic ways to name these molecules. And again, that allows us to name any molecule just by following these rules, and that we can all know what molecule we're talking about just by giving the name. So these names tell you a couple things. One, how many carbons are in the parent chain, the names of substituents, and where substituents are located. So the first thing you got to do when you're naming is identify the parent chain. And the parent chain is the chain with the highest number of carbons. So if you're looking at this molecule here, you would want to go through and find what's the longest chain of carbons I could find. And in this case, it's 9 carbons. So this here traces the 9 carbon parent chain. So it won't always be like what's in a straight line. So here, it's not going to be this. That's only 1, 2, 3, 4, 5, 6 carbons. You have to find the chain with the most number of carbons connected in a single row. And again, that's what we call the parent chain. These are the names we use for parent chains. They tell you the number of carbons. So the number of carbons here will give you this prefix for the parent chain. So you need to learn these. So if you have 1 carbon in the parent chain, the prefix will be meth, 2 is eth, 3 is prop, 4 is bute, so on and so forth. If it's an alkane, then you add ane to the end of the prefix. So ane will be your suffix. So if you have a 1 carbon alkane, it would be methane. If you have a alkane with 6 carbons in the parent chain, it would be hexane. So if we go back here, our parent chain has 9 carbons. So the prefix for 9 carbons is non. And since it's alkane, it'll have ane at the end. So the name of the parent chain here is nonane. Here, this goes on and shows you more. Usually we live within like 1 to 10 carbons, but there are names beyond that. If the parent chain is cyclic, you just add the prefix cyclo. So here I have 3 carbons, so that's propane. And since it's cyclic, I add cyclo to the beginning. So this is cyclopropane, cyclobutane, cyclopentane. Now, there are some weird things sometimes with parent chains. Sometimes we have competing parent chains. So if we look at this molecule here, there's 2 different parent chains I could choose that have the same number of carbons. So here, let's look at one example. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 carbon parent chain. But I have another 10 carbon parent chain I could draw. Starting here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this also has 10 carbons. So you can see here, I have two possible parent chains with the same number of carbons. So we have to pick one. And the rule is that you choose the one with more substituents. And substituents are these things coming off of the main parent chain. So here, these things here, these are counted as substituents. Again, they're groups coming off the main parent chain. So this one has 2 substituents. And then in this version, I have 1, 2, 3, 4 substituents. So again, you choose the parent chain that gives you more substituents. So this would win, and this would be my parent chain here, not this.